We have two strings. We have two strings, S and T, so these could be any values. So this one, anagram and Nagaram, whatever this word is, something ram, Nagaram, something like that. And we were basically trying to figure out if they contain the same number of letters, which can be rearranged. That's the general gist. And if they do, we return true. If they don't, for instance, there's a difference in letters or difference frequencies of letters, then it's false. So pretend there's actually two N's here for whatever reason that doesn't match the one N and the S variable. Okay. So the solution that I'm thinking of is us using a hash map, which is basically just a key value. I wouldn't explain this to an interviewer, but and for the key, we will be using the letter. And then for the value, we will be having the frequency. So for instance, S would have the hash map key A map to the value 1, 2, 3. So in this case, A3, right? After all said and done, right? So my idea is go through a for loop for the for the S string, and in this for loop, add up each letter's frequency, and then do another for loop of T string, and then within that subtract each letter frequency. And then we do another for loop of the hash map. And in there, check if every key's value is equal to 0. If so, then return true. If not, return false. Is the general gist of it. And this is a O(n) space and time complexity, because it's whatever the max is technically. So max of like MN, whatever that is. Where M is the letters in S, is the number of letters in S, and N is for T, right? The reason why I say that is because this could be like a super long thing. Actually, to be honest, we could do a conditional check at the beginning to like skip any of that if they're not even the same size. So that might actually help with some like speed up for like some edge cases. But this is the general format of the solution. So I guess to put it, check if the string sizes are the same. Because if they're not the same, then they don't have, it's not an anagram for sure. Right, so, yeah. So I'm going with this solution since this is the optimal solution. And let's go from there. So just to be consistent with the format, I'm just gonna do this, and m is equal to s dot size, and n is equal to t dot size. Right, and then if m is not equal to n, return false. Yeah. And now we can do the like main check. So now we can do a our what is it? So it's a char and int. We'll call it frequency map. We'll do our hash map, and then we start iterating through the letters. So C with an S. We'll do a frequency map of C plus plus. Because the initial value of this hash map will be 0 for whatever letter it is. And then when we do plus plus, it will add 1 to it. So for the first letter, it sees A, it'll be 1, N will be 1. It sees A again, it will be 2. And then we'll do the same thing. I'm at this point of the code. So char C and T. I guess I am also explaining a bit more than I would, because I'm thinking about the more than the interviewer. I should probably do this more in an interview style, because there's a lot of things I wouldn't have to explain, like such as a hash map. But yeah, let me know if that's helpful or not. So now we have to go through the hash map. I think I could do this. Oh, shoot. Yes. I think I could do this. Letter. Within frequency map. I think I could do. I forgot what this is called. I think they introduced it in 13 or 17. I forget. I would get grilled by some people if I didn't know. Let's do this. We need to complicate it. As I'm complicating it. So if frequency is not equal to 0, return false. This is the one syntax that I'm not too sure of. But if we go through all of them and they are all equal to 0, then we can return true. Yeah, I think that's the case. So let's go through this example since it's a simpler example. Oh, yeah, yoink. Ah, it's Y. I'm supposed to do Y. That's what it is. Paste. Remember things now. I'm remembering things now. So we're gonna go with frequency map. And I'm just gonna go through here. Just saying it. So for the first for loop, when we get to here, it'll do R1. And once we get to here, it will be A1. And for the next one, it would be T1. Right. And then once we get to T, yeah, we start subtracting now. Now all of a sudden we have the C is equal to -1. It literally just added 1 by the end of it. And then we have A is equal to 0, and then R is equal to 0 once we go through this part of the for loop. So we have all these random values, and I'm not really sure what the order of it will go through, but if it goes through here, it'll keep continuing, and it'll continue for this last for loop, excuse me, and then it hits this T, or maybe it hits a C, I don't know. It will see that it's a non-zero, and then it will return false. But for our logic with the top one, it would probably, it should be all zeros, or it will be all zeros, and then we will never get into this if statement right here. So then we will return true. That's the logic behind all that. So that should work if the syntax is right. So let's test it out. Hopefully no bugs. I'm the greatest. I'm the greatest, guys. I still remember a couple things. Wait, what the? You won't get me to case 2? That's crazy, bro. That's crazy. Oh, for some reason I was in some weird limbo state. Let's do Elite submit. Nice. And I think that was just I think this should be the fastest solution. Oh, Ven is very fast. And funny enough, with the follow-up question, with like containing Unicode characters, how would you adapt your solution to this case? Our solution already adapts to that case using the hash map. That's the beauty of this solution, because we use any character, basically, Unicode character. Another solution would be replacing this data structure with a vector. And you would do something along the lines of like this. And it'd be int. And it'd be like fmap. And let's see. You would, I think it's size first and then the initial value. I think that's the constructor for that. So each letter would be corresponding to each letter, or each index corresponds to each letter. So the 0th index, it looks something like this right here. Actually, I'll just type it right here. I can get out of it. It would be like 0, 0, 0, 0, right? So this would be A, this would be B, this would be C, and this is the frequency of each letter. So for our first solution, we would have some like 1 or 2 or 3 for the amount frequency, and that's a different solution. Luckily for us, we're big chillin'. So that's the solution for problem 242, like in an interview style type of answer where we explain the problem, explain a solution or possible solutions if we have multiple, if our mind is running amok. And then we start talking about the space and type complexity. I went a little bit more detail with the data structure, which I wouldn't have to do in an interview, but that's the general case for that. Okay.